human being is just his body. There's nothing more than the body. The body is the whole human being. And in particular, when we talk about thoughts and feelings and ideas and understanding and decisions, all of that is just brain events. It's stuff going on in your brain. It's complicated firings of neurons or maybe some other stuff going on in the brain. There isn't anything more than the brain. Obviously, that is a proposition that we cannot accept. We cannot even consider it as a candidate. It's got to be totally off base from our point of view. Now, what I want to do is, we've used this technique before, put the burden of proof on the true believer, the scientific community. They believe this, they think they know this, they think it's established, they think any educated, intelligent person has to agree to it. Fine. Let's hear their reasons in favor. Let's hear why they think this and see whether they are sufficient. It's no secret that I'm going to say they're not sufficient, and it's not I who am talking, but some of the finest philosophers over the past 40 years who continue to the present to object that this position is one that is not only without reason to accept, but in certain ways may be even patently absurd. Despite the fact that it is the cat's meow on campus, and that the whole university departments like cognitive science are dedicated to believing it and teaching it and propagandizing in favor of it, there is no good reason to accept it as true, and even more, there's good reason, I think, to regard it as, currently anyway, absurd. So let's start down the path. Number one, let's just register the peculiarity of what is being said here. This thought goes back at least to Leibniz and has been echoed over and over again. Let's suppose I open up your brain. What am I going to find? Well, I'm going to find neurons and glial cells and lots of other stuff. And there'll be some electrical current because of the trade of ions at the synapses. And there'll be blood flowing through and neurotransmitters being exchanged and so forth and so on. Will I find temperature there? For sure. Electrical current? No question. Will there be a certain density? Right. Certain balance of fluid and solid? For sure. Now, where am I going to find the taste of sugar? Or the experience of seeing blue? Or thrilling to a late Beethoven quartet? Where am I going to find those things? What kind of things should I look for to find it, the very taste of sugar in the brain? At the outset, it seems like looking for oil in a cloud. It sounds like you're looking for the wrong kind of thing in that context. That's what it sounds like. That's just an intuition. It may be wrong. There may be research and arguments to overcome it. But at the outset, it sounds like it's apples and oranges. Some people have put this intuition the other way around. Okay, so the brain is just a complicated machine. Suppose I built a model of the brain out of tin cans and wires. Okay, lots of tin cans and wires. Billions and billions of tin cans and wires. And I pulled these and jiggled those and so forth and so on. Would I have produced, among other things, the taste of chocolate? Since the taste of chocolate is just discharging of various neurons in certain patterns. It sounds funny. It sounds funny. Okay, that's just an intuition. It doesn't carry the day. It doesn't win any arguments. But it sort of sets a kind of uphill challenge to someone who wants to overcome it. You're telling me, against what seems natural to me, against what seems intuitive to me. You're telling me I've got it all wrong. The truth is something entirely different from what I expect. Okay, I'm willing to listen. And I want you to show me how to overcome that initial sense of bizarreness that we're looking in the wrong place. Okay, so now the believer says, I have it. I have the reason that should convince you that the taste of chocolate and the vision of blue and the thrilling to the Beethoven and the rest of it is nothing but brain events. And here it is. We have done extensive study and we see there's a correlation between the taste of chocolate and certain brain events, the seeing of blue and certain brain events, the thrilling to Beethoven and certain brain events. We have mapped massive correlations between you and me. They're lying about this. But let's leave that aside. It's just a great exaggeration. But let's suppose we've mapped correlations and we see that every time you taste chocolate, these brain events take place, and vice versa. Whenever we stimulate these brain events, you taste chocolate, and vice versa. We have a correlation between all of the things you think of as your feelings and thoughts and decisions and experience on the one hand, and brain events on the other hand. We have a correlation between the two of them. That's why we think that all of your experience is nothing but brain events. Okay? Is it clear what I'm saying? And that's what they do in laboratories. They do massive experiments of, they ask a person, think of the word epigee, and then they do an MRI to figure out where the blood flow is in your brain, and they correlate the blood flow to the thought of the word, and they prick you with a needle and see where the blood flow goes in the brain. They say, oh, see, when you're pricked with a needle, you have that pain, then the blood flow goes over here, so that's the part of the brain that's active. Those kinds of studies. Now, many philosophers have raised the following extremely simple logical point. Correlation between two things is not the same as their being identical. Indeed, very often, correlation means A is A and B is B, and just whenever you find one, you find the other correlated with one another. That wasn't what the scientist was telling us. He wasn't telling us they were correlated. He was telling us they're one and same thing. Here's John Searle's example. Lightning and thunder are correlated. When you have lightning, you have thunder. When you have thunder, you have lightning. Lightning is one thing and thunder is another thing. They're not the same thing. They're just correlated with one another.
Can't you disprove that by trying it again over a period of time?
You can prove or disprove whether they're correlated by trying it over and over again, yes. And if they're really correlated, then every time you try it, they will show up coming in tandem, one with another. But all that shows, even if it goes on forever, under all possible conditions, it only shows that they're correlated. It doesn't show they're the same thing. How many times would you have to test lightning and thunder to conclude that they're the same thing? Lightning and thunder are clearly two different things. One is the transition of electrons, and the other is sound waves in the air. They're two different things. They just happen to be correlated. If a free body starts to accelerate, you know a force was applied. Accelerations are produced by forces. Forces produce accelerations. Forces and accelerations correlate with one another perfectly. It's just that applying a force is one thing, and accelerating is another thing. They're just two phenomena. They happen to be correlated. So I say to the scientific community, listen, I started with an intuition that there's a gap here. You show me that the things are correlated. I wasn't worried about that. My intuition wasn't against that. Indeed, I'm going to tell you something very shocking to the scientific community. I believe in a soul, and I believe that what happens in the brain, what happens in the soul, are correlated. I do believe they're correlated. So I agree with your correlations. Your correlations for me are perfect. I'm happy with them because they confirm my point of view. They're correlated. But you're telling me, no. They're not just correlated. There is no soul. There's only the brain, and the whole story is what's happening in the brain. Well, frankly, I need something to get me beyond correlation which tolerates that there are two separate things that are related to one another, to your position, which is identity, that there's only one thing, what's going on in the brain, and that's all there is. I need something to get me over that gap. And your laboratory studies aren't going to do that. Because all the laboratory studies show is that there's a correlation. A correlation could be a correlation between two different things. Yeah.
Sorry, I don't want to interrupt mid-argument, but
No, that's fine. Yeah.
so I'm not sure all the different studies that go along with the correlation or how the relationship between like different centers of the brain and what actually specifically there are. But I recently just happened on a radio podcast where a treatment for epilepsy is brain surgery, and by doing so, there's side effects of kind of like a lack of self-control, and like it's correlated, like they're like without that part of the brain, if they take out too much, without that center, like there's a certain personality, like character trait where they just like they lack that discipline, like that's been shown. So I wasn't sure how that fits in with if the brain was all there is, or then wouldn't it make sense that with it gone, then that trait would also reflect that? If it was something else, let's say the soul, then it would still occur, but the correlation of part of the brain, like that wouldn't really be a part of it. Does that make sense? What I'm saying?
It makes sense, but I don't think it's correct. We're considering two propositions. One is there's only the brain, and that's all there is.
Yeah.
And the other is that there's a perfect correlation between what happens in the brain and what happens in the soul. Those are the two propositions. Now, it seems to me what you're reporting, and by the way, this goes back more than 150 years, injuries have been reported that have systematic effects on personality and other things. It seems to me all these studies are equally explained by the two ideas. If you think that the brain is all there is, then of course you expect when a piece of the brain goes dysfunctional, it's going to be a big difference in the person's operation. I agree with that. But now consider the alternative proposition. The alternative proposition is that the brain and the soul are perfectly correlated. They're correlated so that what one does, the other one does. So when you knock out a piece of the brain, the soul is going to be unable to function because they're correlated. Isn't that equally an explanation for what's going on?
That would make sense, but I feel like you're complicating it.
Okay, but one step at a time. You offered a thought that these studies count specifically in favor of there only being the brain, on the one hand, versus there being a brain and a soul. They don't. They're equally explained by both. Now you have another objection. The other objection is, if I can explain it without the soul, and you are putting the soul in, that's extra stuff. We should cut it off with Occam's razor or something. That's a separate issue, a separate objection. It's nothing to do with the first objection. First objection was the experimental results cut in favor of this and against that. They certainly do not. The experimental results are explainable by both propositions equally. Okay. The idea of putting in an extra element, that's philosophy, and that's debated and discussed. And if the experimental results really did cut in favor of one against the other, that would be conclusive. If you could really show on the basis of a brain study, a brain injury, that only the single brain idea could explain it, and the brain-soul correlation couldn't explain it, then you'd have a very strong argument against the idea of a soul. But since both can explain it equally well, so then you don't have an experimental result that counts for one and against the other. You have a methodological complaint that this is a more complicated theory, so we should go with the simpler theory. That doesn't show that the more complicated theory is wrong. We don't always go with the more simpler theory. It's a very complex business of when we go with the simpler or not simpler. There's numerical simplicity, conceptual simplicity, postulate simplicity, and they conflict with one another. You can look it up under Occam's razor on the net. It's a very complicated and subtle methodological matter. It's not at all like having an experimental result that shows that this is right and this is wrong. That's where you started from. The experimental results show the single brain picture is correct and the correlation picture is incorrect. That's not correct. Right? Does not show that because both can equally explain it. And again, I'm not telling you anything that's not. This is obvious to the people who are writing in the subject. Okay, so now the question will be: can you, the believer in the scientific picture, get me over this hump? Can you get me from correlation to identity? And the scientific community says, I think we can, because we've done it in the past. We have actually succeeded in moving from correlation to identity. Science does lots of things, and from time to time, science discovers identities. Yes, it does. And there are many such cases where science discovers identities, and the scientific proponent will have to say, and this case is like one of those, and we'll fit it into the pattern of one of those. And we'll show you how we can get from correlation to identity. For example, science has discovered what sound is. Up until maybe 200 years ago, no one had a clue what sound is, what it is. All we knew is when you bang drums, you make it, and sound causes you to have certain experiences, but what is the sound itself? No one had a clue. And the true answer, I think, would not have been dreamt of by anyone older than 200 years ago, that it's patterns of motion of particles of air, waves of air. No one would have dreamt of that as the right answer. Science discovered that sound is systematic air motions. Science has discovered that heat is random molecular motion. That's not obvious at all. Science is just a kind of motion. Heat is just a kind of motion. Indeed, an older theory, I'm not good at the dates, 200 or 300 years ago, thought that heat was a fluid, a kind of very thin fluid that you can't see. Hot things have it, cold things don't. When you put the hot and cold together, the fluid seeps from the hot one into the cold one, and that's why the hot one heats up, and that's why the cold one gets cooler. The hot one gets cooler, and the cold one heats up, because the fluid is flowing. Right? And that turned out to be wrong. Science discovered that heat is random molecular motion. These are identities. Science discovered that water is H2O. No one dreamt of that before molecules were concocted 150 years ago. Once molecules were concocted, who says it's H2O? Hydrogen is a gas. Oxygen is a gas. Would you have guessed that water is made out of two gases? But science discovered that. So the thought is, science is in the business, among other things, of discovering identities. And if you use the same scientific method that showed us that heat is random molecular motion, and that sound is airwaves, and that water is H2O, and all the other things that have been discovered, you'll see that science could discover that toothaches are brain events. And thrilling to Beethoven is also a brain event. And tasting chocolate is also a brain event. The same way. Surprising, unexpected. All the other ones were surprising, unexpected also. And this is all surprising, unexpected. And there's also something which science can do. That's the proposition. Use the same methods that science has used for successful identities and apply it here to show that you can make an identity here as well. Are we together so far? So, the next project is, let's analyze how it's done in the cases where science has been successful in showing identities, and then see whether that method can be applied to the taste of chocolate and thrilling to Beethoven and decisions and understanding as identical to brain events. That's the investigation. So, in order to conduct this investigation, we have to spend a little time understanding how science does it when it's successful. And the truth is, there are two models for how science does it when it's successful. There's a simple model and a more complex model. And I'm going to introduce both of them because it'll turn out that the one that we need corresponds to the more complex model, and that's why we have to have it on record. Well, let's take the simple model. Let's think about how science went about discovering that sound is airwaves. What did science know about sound? People, ordinary people, know about sound before the discovery. Well, they knew a considerable bit about sound. First of all, they had a list of things that cause sound. Banging things cause sound, and vocal singing and speaking cause sound, and fires cause sound, and motions of trees cause sound. And we know that sound causes certain experiences, auditory experiences. And we know that sound behaves something like a physical object because, for example, if you build a container that's very solid with no holes in it, no pores in it, and you make a sound inside, you can't hear it outside. It seems like the walls can stop it. The walls can actually block sound. Walls stop physical objects. So it seems like it's behaving like a physical object. Echoes. You make a sound here, there's a wall there, and somebody hears over here, it's coming from the direction of the wall. Seems like sounds can bounce. Sounds can bounce off walls. When you make a sound, the farther away you are, the less loud it is. Seems like over the distance, the sound is sort of fading away, diluting away. These are all things that physical objects do. So sound behaves a lot like a physical object. It's just that no one had a clue what the physical object could possibly be. You know, if you're over there with a snare drum and he's over there listening, you bang the drum and he hears it, and I stand here with my hand out, I don't feel anything. I don't feel anything. So how could it be a physical object going from there to your ear and I don't feel anything? How could that be? What could it be? Hidden rays? I mean, it was very peculiar. It behaves externally like a physical object, but what this physical object is, no one had a clue. Now, there's a name for this in the literature. Those with good memories will remember that I talked about this a couple of weeks ago in an entirely different context. And that is that we're getting a description of what sound does without getting a description of what sound is. And in the literature, this is called a functional description. It's a functional description of sound. I know a lot of things that cause sounds. I know a lot of effects that sounds have. I know a lot about the behavior of sounds. I just don't have a clue what it is that's doing this. What is the thing, the physical thing that's doing this? Now, the way the procedure works is this. Make a list of all the things you know about what sound does. And there's a lot. And then you say, well, let's hunt. Let's hunt. If we can find something that does all of this, then it's reasonable to say that we found sound. Since this is all we know about sound, and we don't know this about anything else, if I can find an X, butterscotch, that does all of this, or pixies that do all of this, or cosmic rays that do all of this, they're produced when you bang snare drums, and they're produced in fires, and they're produced when people speak and sing. And these pixies or butterscotch hit the eardrums and cause you to have auditory experiences. And when you set up walls, the butterscotch doesn't pass through. And when the butterscotch is free, then it bounces off walls and creates echoes. If the butterscotch does all of that, then it's a good reason to say that butterscotch is sound. Because you started off with a functional definition of sound. For me, sound is whatever does all this stuff. That's what I know about sound. That's what I'm introduced to in sound. That's how I experience sound. Sound is whatever does all of this stuff, but I just don't know what it is. I just know what it does. I'm hunting for what it is. Find something that does all of this stuff, and that's reasonable to say that that's what sound is. Heat is the same sort of thing. Same sort of thing. I know lots of things that heat does. No one had a clue what heat was. Indeed, I told you. At one time they thought it was a fluid. Hot things have this very subtle fluid that's in there, and then when you put them together, the fluid flows from one to the other. That turned out to be wrong. That's not what heat is. Heat is random molecular motion. So, when you start off with a functional definition, fourth time, because it's going to be very important, you got something, what you know is what it does. Conditions that cause it, effects that it has, conditions under which it operates, you just don't know what the thing is, and you find a cue that has all those functional features, then it's appropriate to say you've discovered what the thing is. It is that cue, because the cue has all those functional features. Start with a functional definition. You find something that meets the definition, then that's the thing, the item itself. And that's what happened with sound, and that's what happened with heat, and the answers were very unexpected. So intuitions don't count for much when you have an argument like that. Intuitions go down the drain. I don't care whether it sounds strange to you or impossible to you. I think Thomas Nagel asked 300 years ago, asked somebody, could you imagine weighing a sound? Weighing a sound? I think he would say, I don't know what you're talking about. Can you weigh a sound? But today we could weigh a sound. If the sound is just the systematic motion of the air particles,
Measure it.
you can measure its intensity, but why not? If it is the motion of
Not
these,
physical, you can measure it. Like,
well, you could weigh the air, couldn't you?
you can't weigh air.
Sure, you can. Air pressure is what causes effects right here at sea level. When you go up to higher on a mountain, there's less air pressure. Of course, we're weighing air all the time.
You can weigh sounds.
if the sound is just the motion of this air, you can weigh the air that's moving. That is the sound. The sound is that air in motion.
But it's not a physical weight. It's measured under
Why
a
not?
different.
Why not? Air pressure is a physical weight. It's just the pressure of the atmosphere above you. A certain portion of it is moving in
No, I
this
know you can
systematic way.
Measure sounds like in music, like beats per minute or something like that.
Right, and you measure pitch, and you can measure overtones and intensity and all the rest.
But that's not
But
like a physical.
correct, but there's something else, because since the sound is the airwaves, it's the motion of the particles of air, and you could weigh those particles of air. Particles of air are physical things. They have a weight. A certain amount of air has a weight in pounds.
You could do that for sounds as well.
Sure, why not? So I'm pointing out here something which the critic should be sympathetic to. I'm throwing a sop to the critic. See, your intuition isn't worth much. You would have thought that weighing sounds is just unthinkable, but when you find out what sounds are, then all of a sudden it becomes natural and normal to do that. So your intuitions aren't worth much. Don't pay attention to your intuitions. Science can overcome intuitions, right? Celebrating the glory of science. Good. That's one pattern, where you have a functional definition of a thing, and then you find something that fills that functional role. You have a right to say you've discovered the thing itself. You've found an identity. But not everything is like that. In other cases, not only do you have a functional definition, but you also have samples. You have direct samples of the stuff. Let's take water. For water, I have lots of functional information. I know how it behaves in millions of different ways. I know at what temperatures it's liquid, at what temperatures it's a gas, at what temperatures it's a solid. And I know that it nourishes plants, and I know that it can drown people, and I know that it dissolves various things, and I know that it has magnetic properties because the water molecule, that's what we say today anyway, the water molecule is magnetically unbalanced. I know ways to produce it. Condensation out of the air. All those are the things we know about water. That's all functional information, like sound has functional information. But we also have glasses of it, and rivers of it, and seas of it. So here, in order to discover what water is, you need a double investigation. Number one, you need to investigate. If you think water is H2O or something else, check whether H2O does what water does, just like in the case of sound. See that the molecule that you are proposing, that is water, actually behaves in the way that water should behave. Will conglomerations of H2O become a solid at 0 degrees centigrade? Or not? Will they become a gas at 100 degrees centigrade? Or not? Will they boil and bubble with gyrations of air together at 100 degrees centigrade? Or not? Will they nourish plants or not? Will enough of it drown people or not? What kind of functions does collections of H2O have in such a way that you'll see that it matches up with the functions that water has? But that's not enough. I need reason to think that what's in my glass is H2O, because I have actual samples of it. Do we have any reason to think that what's in the glass is H2O? Sure, because if you pass an electric current through water in the glass, it will dissociate into hydrogen and oxygen. And the interpretation is the energy of the electrical current breaks up the water into its components of hydrogen and oxygen. You're sort of pulling the water apart and finding that it's made of hydrogen and oxygen. That's pretty impressive. Also, there are ways in which you could take hydrogen and oxygen and combine them into water under certain conditions. So now it looks like you have a double investigation. H2O does everything that you've discovered through your experience that water does. And what's in your glass is H2O, because when you pull it apart with energy, it becomes hydrogen and oxygen. And when you take hydrogen and oxygen and put them together, they do become water. So now I have both ends of the investigation covered. And that's what's needed to enforce an identity when you have actual samples of the stuff. Let me explain why they're both needed and show you what would happen if you had one without the other. And then we should discuss this for today. Then tomorrow I'll go on to make the application, but it's enough new material for today, I think. Let's suppose you had one without the other. See, here I am. I'm a chemist, super chemist. I got H2O, and I say, when will H2O become a liquid at 0 degrees, from 0 to 100 degrees centigrade? And lower, it'll be a solid. And higher than that, it'll be a gas. And it'll boil at 100 degrees centigrade. I do all these calculations. I see that H2O really does all this stuff. It nourishes plants and so forth and so on. But when I pass an electric current through water, the water in my glass, I get utterly different constituents. Sulfur and iron oxide and molybdenum. I say, well, something's going wrong here. Something funny's going wrong here. H2O does all the stuff the water does, but the water in my glass doesn't come out to be hydrogen and oxygen. I think then someone's going to be suspicious. Maybe H2O does everything water does, but maybe something else also does everything that water does.
Either that or they're not the same.
And maybe, therefore, H2O is just a surrogate for water. It could do, but it isn't what water is. Because when I work with the water in my glass, I don't get hydrogen oxide. I get something else. And then I would take the stuff in my glass and try to find another chemical compound. And I would test that other chemical compound and see if it doesn't do the same thing. And then I would say, well, I made a mistake. Because H2O only mimicked the functions of water, but it didn't apply to the stuff in the glass. Or the other way around. Imagine I say it's H2O, I pass the electric current through, and I get hydrogen and oxygen, but it doesn't do the functions. I pour H2O I make H2O in the laboratory, and I pour it on waters and they die. And I pour it on plants and they die. I try to freeze it, it never freezes, no matter what temperature you get. It has all the wrong functions. Then I think what we would say is, you know what? When you passed the electric current through the water, you changed it. You only got hydrogen and oxygen because you ruined it. You messed it up. You didn't just peel apart its building blocks. You changed it in a certain way and got something else. Because the H2O you make in the laboratory doesn't do what water does. So when you passed the electric current through it, you weren't getting its building blocks, you were messing it up. You were changing it into something else. You really need both. You need to have what your suggested definition is. Both should do the functions, and you should have some way to peel apart the samples that you have and find that it really is made out of what you say the building blocks are. If you can't do both, you haven't got a good reason to say it's an identity. That's because in the case of water, unlike sound, in the case of water, we both have the functions that water fulfills, and we have samples. In the case of sound, we only had functions. We didn't have a bottle of sound and say, here's a brown sound. Keep it on the shelf and make sure you use it in your experiments. We didn't have any sound at all. Sound was a total unknown. Water's not a total unknown. We're surrounded by it. So in the case of water, we have a double set of data. We have its functions and we have samples. The discovery of its identity has to satisfy both. It has to be something which will indeed explain all the functions, but also we can have good reason to think that the samples are made the way you say it's being built. And then you have both, and in the case of water, we do have both. So then we can say we've discovered what water is. Now, the difficulty is going to be this. In the case of experience, usually in these discussions, to make it simple, not repeat all the categories over and over again, I take a toothache. In the case of toothaches, we have a lot of functional information and we also have lots of samples. Lots of samples. Everybody has had toothaches. If you haven't, you're lucky. So take another ache, a headache. Everybody's had pains, right? And what we have to check is that the thought that we're dealing with brain events satisfies both criteria. Does it play the right functional role? And do we have reason to think that it's made out of neurons? And the argument's going to be that yes, it plays the right functional role, but saying that it's made out of neurons is going to be a disaster. Okay, I'm just foreshadowing what we'll do tomorrow. But up to here, we've got sound on the table, and water on the table, and a description of how science comes to the conclusion that it has discovered the identity of sound, and how it comes to the conclusion that it's discovered the identity of water. In the case of sound, it's a single criterion. You've got a functional description, a functional definition. Only function. All you have is function. You have no samples. There's no bottled sound that you can say, here's sound, let's take a look at it. All you know is sound is whatever does this job. So you found something that does the job, air motion, and you have every right to say, I've discovered what sound is. In the case of water, you have double data. You have the functions of water, and you also have the samples of water. In order to say you discover what water is, you need to take your proposed definition, your proposed identity, and show that it fulfills all the functions, and you have reason to think that the samples are indeed what the definition says. And if you have that, as you have in the case of water, you have every right to say you have discovered what water is. It's not just a correlation, you've discovered its identity. And the question will be whether we can apply that to toothaches and brain events. Is the pattern clear? Questions up to here? Yeah.
Are you gonna apply these to the soul and the brain waves and all that?
Okay, what I'm going to do is show you, this is the argument that I'm directly using, that there is very good reason to think that the brain isn't everything. Once you have good reason to think the brain isn't everything, then you have to begin to question, well then what else could there be? How could it be? How could it exist? How could it be related? That becomes a very interesting study. I'm fighting with a person who's convinced that he knows the brain is everything. That's my target now. I asked him for his reasons. I've got him in a position now where he says his reason is because he can show that toothache and brain are just like water and H2O. Science discovered that water is H2O. Science will discover that toothache is brain events. I want to see if you can make that stick. If you can't make that stick, and if it's not just an accident, not just we haven't got enough research, let's wait another 100 years till we get more research. No, it can't be a problem like that. It's got to be a problem in principle. It's a problem in principle blocking this move. Then I say to the scientists, you have not only have you no good reason, but we have very good reason to be skeptical that you will ever discover that toothache is an event in the brain. All you will get is more and more exquisite correlations. But correlations do not enforce identity. That's where we started from. Correlations tolerate that there are two different things in sync with one another. If we have an argument in principle against making an identity claim, then we have reason to think that the brain isn't everything. Then we'll have to, assuming we have time at the end of the week, I'll talk about how we can describe what the extra thing is and how it's related, so forth and so on. Yeah?
Would it make sense now to ask your definition of what we're saying the soul is?
No, because as I said, I'm playing against the person who knows it's only the brain. He knows it's only the brain. I want to see, can he fulfill his position or not? If he can't, he doesn't have to admit to a soul, he can admit to a mystery. But he can't fulfill it, so then we have to go on and talk about what the alternatives are. But I'm not going to talk about the alternatives until I put him in a corner and say, he can't have that position. He can't, right?
I'm just curious relating this to Judaism, where the toothache fits in with the soul. Because I never thought any relevant to what a soul is.
Okay, from our point of view, the soul is where all of experience takes place. That includes pain, it includes sensation, it includes the thought, it includes the will. The soul is where all of that takes place. Other things as well, but all of that, what in philosophy is called the mind, which is a very special term in English, especially in philosophical English, the mind. Mind is not just what you think with, but feeling and emotions and fears and the subconscious, all of it is in the mind. What in English is called the mind is what we would call the soul, roughly. There's more to it, but it includes all of that. So it definitely includes toothaches. Toothaches take place in the soul.
That doesn't happen in your brain?
No, it's correlated with an event in the brain, but it doesn't happen in the brain. It's correlated. It's correlated. Just correlated.
What are you trying to prove?
I'm trying to show that the idea that there's only the brain is an idea that can't be accepted.
Not correct.
But that's not correct, right? Number one, that
Idea is incorrect.
that it is incorrect. Yes, and I'm glad you're putting that because I'm sort of making a double move here, and I distinguished them in a previous discussion. So it's important you're pointing this out. Number one, there certainly isn't good enough reason to believe that it's only the brain. But more than that, there seems to be an obstacle in principle against saying it's not that there isn't enough reason yet, which would just challenge the scientific community to come up with more reasons. No, there's going to be an obstacle in principle against saying that it's in the brain. That's going to be the problem. And then if you recognize it's an obstacle in principle, then you think in terms of alternatives.
What is an obstacle?
Well, I'll say it to you, but I can't verify it to you today. It's a conceptual obstacle. Thomas Nagel, who's been writing about this for 30 years, one of the leaders in the field, puts it this way. I've used this idea today, I just didn't give it a name. There are some things, concepts, which come with a built-in hole. A hole which is to be filled in someday, later, sometime, somehow, and filled in a particular way. The very concept carries with it the idea that it's incomplete, there's a hole there, and the hole can be filled in by a certain procedure, and when you do succeed in filling it in, so then you really have the essence of the concept. And that's concepts of physical objects are built that way in our conceptual system. I don't know if this would have to be so in every conceptual system. But in our conceptual system, the concept of a physical concept, the concept of a physical thing, has a hole in it for its structure. The thing is the structure out of which it's made. What is the cell? What is the cell? At a certain point, at very primitive microscopes, you could just see cells. But we have a commitment. The cell is a collection of things. Once you make a list of all the collection of things in the cell, that's what the cell is. The cell is that collection of things. You see a clock. The clock is keeping time. What is the clock? Well, there's something going on inside. Maybe there are wheels and gadgets. Maybe there's a person, you pay there, he's turning around. Whatever it is, the clock is the innards that are moving around, keeping the time. That's what the clock is. Take it apart, look at its pieces, see how the pieces fit together, and that's what it is. Physical things, in our conceptual scheme, physical things are built with that empty space. Go to the structure and use the structure to explain what it does, and that's what it is. The thing is nothing but a collection of all that stuff that's in its structure. Now, it didn't have to be that way. Some philosophers have pointed out different conceptual schemes could have worked differently, but our conceptual scheme works that way. And it's been very successful in that respect. Because when we take things apart, we do get understanding of how they do what they do and why they do what they do. Fine. Not everything is like that. Not everything is like that. Not everything has a hole for structured pieces which you can build it out of. It's not obvious that the concept of a toothache is like that. The concept of the experience of a toothache is something which automatically has a hole for inner structure. Take it apart into its little pieces and see how the pieces work, and then you'll get the whole toothache. Because the toothache, at least on the surface, is not thought of as a physical object. It might be that science will discover it, but in our conceptual scheme, it's not like a table or a chair or a puff of smoke. So that being the case, it's not obvious that you're going to get to a point where you can marry two concepts. A concept of a physical object which has built into it a hole for structure, on the one hand, and a concept like the concept of an experience which doesn't have built into it a hole for structure. So Thomas Nagel says, in order to overcome this gap, what we would have to do is undergo a conceptual revolution where our concepts of experiences changed into concepts that had these built-in holes for structure, and then we could marry it with the physical. But that's a conceptual revolution, and you don't get them by waving a magic wand or talking about it. It requires an Einstein to do a conceptual revolution. And in the meantime, betting on a conceptual revolution is betting on a dark horse. And he writes, as a card-carrying atheist, which he has written in 3 books already, that he's definitely an atheist, he said, I believe someone who believes in a soul could gain some comfort from these reflections, that in order to defeat the idea of a soul, you have to predict a conceptual revolution. That's going way out on a limb. That's not like doing finer experiments in the laboratory with more finer electrodes or more electrodes for more neurons and so on and so on. It's not like that at all. It's changing your conceptual scheme.
He says people just made up a soul to answer all these unanswered
No, he's not doing history of religion. He's just talking to the concept. He's a philosopher. He's not talking about why people made things up. That's irrelevant. That's just puerile, false history. In philosophy, we have something called the genetic fallacy. It came from there, and there was dumb, so therefore it's got to be dumb. That's called the genetic fallacy. Where it came from is totally irrelevant. How did you learn arithmetic? Well, you learned arithmetic in second grade from a teacher who you were afraid of. So your whole grasp of arithmetic is no better than your fear of your second grade teacher. Probably wrong, right? Yeah. That's genetic fallacy. So I don't care why people made it up, all that kind of stuff, primitive people, so forth and so on. That's just a genetic fallacy. Cancel that. That's a dodge. If you have to go there, that means you have no good arguments. That's a dodge. Question is, what role does it play today? What evidence and arguments do we have in favor or against? The fact that what it came from in history is totally irrelevant. That's a way of dodging the issue. Okay, we'll go back over this tomorrow, and I'll try to push on to the problem of two things.